Waleed Akbar, and I'm from Packet Optical Network Services Research Group from CTTC, Barcelona, Spain. Today, I'm going to talk about automating the management of IP over DWDM networks based on TFS, how we are utilizing the Teraflow SDN controller in this context. So first of all, I will just give you a very quick uh, introduction about what is IP over DWDM. Uh, IP or DWDM means that you are using an IP network on the top of wavelength deviant multiplexing network. This can be achieved by the use of the pluggable transceivers that we can directly install on the routers, and this will enable us to directly transmit the packet data onto the optical network. So as you can see at the bottom, on the top we have the IP layer, and at the bottom we have the optical layer. So we can directly create a virtual path on the top, and based on that virtual path we have actual physical path in the optical network, which will provide us a more bandwidth and the less cost. So in this way we can transfer the data in less amount of time. So okay, once we introduces these pluggables inside the network, this will give us some problem, like who is going to manage this pluggable? Because the pluggable lies in the middle of two domains. The one side of the pluggable is connected with the IP domain, and the other side is connected with the optical domain. So the question lies is which controller or which entity should be responsible for the management of this pluggable. So we come up with the four possibilities that can be possible that we can manage the pluggable. These one of these ways we can use to manage the pluggables. I'm not going into the detail of this one, but I'm just going to tell you what may be the reasons we have selected the one that we are going to use. So the third one we have selected the third option, that is to give the control of the pluggable to the packet controller. That means the packet controller is responsible for read and write access onto the pluggable, and the optical controller will only be responsible for reading. It cannot edit or it cannot configure anything. So that is the reason we went for this. Although there is still be a complexity of the IP controller that we need to manage. If you compare this scenario with the all other three scenarios, the complexity is bit less, and you will have a more control. So that is the reason that we have selected this third option for the configuration of the pluggables. So how we are going to implement this third option that I discussed, that this will provide IP controller with the read and write access, and the optical controller with only read access. Okay. Okay, so before this, the first step, the IP controller is already configured the pluggables, and it has with the default parameters, and the pluggables already exist inside the network. So first step for the optical controller is to discover the pluggable and its capabilities. So after that, once the optical controller has this information, it will forward this information to the orchestrator. And the orchestrator then requests controller for the service planning. Then the optical controller will compute the pluggables and the media channel configuration. After that, the optical controller will respond to the orchestrator based on all the calculations, the ETSI service. Then after that, the orchestrator will send a media channel request towards the optical controller, and then it will do the optical controller will perform the OLS configuration based on the media channel request. Okay. Once this is done at the optical level, then the orchestrator will request IP controller to configure the pluggables based on the OLS configuration and the OLSI service response that is received from the optical controller. So packet controller will configure them, And then it will also configure the IP link configurations. Then it will create a packet flow configuration, and then it will configure the routers. So this is how we were able to configure the pluggables based on these three instances of two controllers and IPWDM orchestrators. All these three instances are the Teraflow instances that we are using. So how we did this thing is, this is the one of the demonstration scenario that we presented in OFC this year, where we have the top level service management orchestrator that is in Greece in Ubitech. Then we have in the middle the end-to-end orchestrator that we have at the Telefonica in Spain. And then here in CTTC, we have the packet controller. And at the bottom side, the optical controller with the routers and the pluggables, everything we have there in Cadiz in Italy. So we implemented a same concept I just explained on these in this demo setup. Okay. So this is the internal structure of our Teraflow SDN instances, how we are doing it. On the top, we have one instance of the Teraflow, and the SBI of the Teraflow is being used to control both the IP SDN controller and the packet optical SDN controller, and you can request or you can push the configuration through their NBIs towards the respective networks. And some of the components that we are building that was newly built in this for this demonstration is end-to-end orchestrator for the orchestrator. Mm, VNT manager, that is virtual network topology manager from the IPSTN, and the pluggable components also for the IPSTN. And then in the optical SDN controller, we already have a component named as OptiAir controller. We enhanced its capabilities for this specific demonstration. Okay, so this is the screenshot that I took from the GUI of the Teraflow. That is the end-to-end Teraflow. As you can see, at the end-to-end Teraflow, you can see that there are two Teraflow instances. One of them is managing two routers, and the other one is managing the ROADMs and the pluggables. And this is how you will see on the top the connections between the controllers and all the network topology. Okay. What we are doing or how we are automating this whole stuff inside the Teraflow, we have introduced the new components that we are calling a closed loop automation component that provides full closed loop automation inside the network. And they are consist of like majorly these 5 components, but they will work together with the other components to make it work. So the component is the KPI manager, analytics, telemetry, automation, and policy. These are the major components that are going to complete a closed loop inside the Teraflow. Okay, so this is what the ETSI ZSM closed loop automation says. This is first you need to observe, then we need to analyze, then make a decision, and after that you need to act. So this is how all our 5 components that I explained are going to map onto this ETSI ZSM closed loop. So first of all, in the observe category that you can observe the information, we have a KPI management and telemetry module. There you can define what you want to monitor, how you want to monitor, and where you want to monitor. Then you have an analytics component inside the TFS that is responsible for what, when, and how you want to analyze the data. And then we have a automation component that decides what, when, and where to take an action. We can different type of policies you can define here, actions. And based on these actions, you need to generate new policies. And the policy component is the one where you need to push the policies to the network, and it then contacts other components of the Teraflow to actually update or reconfigure the network. Okay, so this is the internal components of our automation framework, how different sub-services of this whole closed loop or work together. Okay, if you see from the left side, we have a telemetry, and with the telemetry, we have this KPI manager. So in this flow, first of all, the automation network will receive a request from the top to automate some scenario. Based on the request parameters and the configurations, it will create some KPI descriptors through the KPI manager NBI. Then once it have the KPI descriptor, it will create some telemetry collectors. Once the telemetry collectors are running, this means you are getting the data from the network. And when you have the information and the data available to you, then this automation will go to the analytics component. And this analytics component, actually, the automation will configure some analysis conditions or any type of analytics you can configure. Then once the analytics is configured, it can receive the data from this bus. The telemetry is actually reading the network from the network data, and it is pushing all the information to this message bus. And then analyzer is reading this information from here. And once it have this information, it will push the information. As you can see, the information is going to the analyzer and it is coming back from there. So the analyzer is analyzing the condition and it is pushing the flags onto the message bus. And here we have this KPI value API. It's a wrong arrow. It should be upwards, where it is catching all the flags from this message bus, and based on the condition, it is informing to the automation all the flags that are being getting activated, or all the alarms that it is getting. Once the automation will receive these flags or these alarms, it will inform policy to take an action on these alarms and or these flags, and the policy will generate a new type of configurations or reconfigure some services. It will push those policies or new configurations toward the service or the SBI components that we have inside the TFS, and then these services are being propagated to actual network, and where it is getting the network is getting reconfigured, and again the cycle will start again from here. So this is something about, yeah. In the middle, we have this this KPI value writer, where we have this database and we are storing all the information in this time series database. We have the Prometheus as well as Grafana Mimir, and also the Grafana for the GUI, where you can visualize all this information. Okay, so that's all. What I have presented in this, that TFS can fully is a tool that is fully autonomous and end-to-end network management across IP and optical domain, and where the TFS automation framework is aligned with the ETSI ZSM closed loop automation and enabling closed loop cycle and reduce provisioning time. Thank you very much for listening. If you have any questions, you can ask.
Thank you very much, Waleed, for this exam presentation. Is there any question?